Good evening. How you doing? Welcome, welcome. Welcome, 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 welcome. Hello. Bridgewater, drunk at Time Lord. Hello. Hello. So, yeah, I'm going to do some more StudyBox stuff today. I'm not planning on doing more recording of stuff. Feynman lectures. Okay. All right, shit. Nice. I need to actually get around to watching those. I've got so much shit on my to watch list. But yeah, so I don't think I'll be recording any playthroughs tonight. There's one more with the English tapes I need to go through. I need to redo. Excuse me. That's number 3 because I got stuck somewhere. Yeah, I'm gonna dig into some other stuff. Jinxie, wow, Jinxie, thank you for 45 months. Appreciate that. How you doing? So, remember the other day when we had the synchronization issues with number 12, right? Where at the very end, did I save that? I don't think I saved it actually. No, it was 11. It was 11 at the very end of this one, right? During this crap here, the sound was not synced like at all, right? It was very badly out of sync, and I was able to take one of, I think it was one of the ones I actually recorded myself and redecode that, and it fixed the syncing issues. So I remember having similar issues with the very first tape. Excuse me. So in the very first tape, which I also re-recorded, by the way. I don't want to hear anything right now, though. This scene right here, it started to get like really, really out of sync, right? So I wanted to try and re-decode it. So I did from the original audio from 4 years ago at this point. I got the same offsets, essentially. The same not great synchronization with it, right? So I wanted to try again with the new recording, and it just didn't want to work, like, at all. We'll get to that in a second. I should start right there. That works. Why are you so large, actually? God damn it. There it goes. All right, minimize you. So if I go into here and then bin debug net output, you can see here that it just didn't want to actually export anything, right? So this is, I think, the original recording I had from January, right? All kinds of freaking errors in the tape, right? It's just, well, not even errors. This is like the only error right here that has. So I re-recorded it from one of the tapes. I mean, this isn't one of the original tapes. I am using one of the duplicated tapes. I'm probably going to dig out the original here in a few minutes. I'll show you why in a second. So I re-recorded it, half an hour of that, and I'm getting all kinds of errors now. Now these, oh boy, turns out half of this, or I suspect most of this is because the program expects a certain bit rate and a certain sample rate and all that kind of crap. And I didn't have it in that. It expects 44.1 kilohertz sample rate. I recorded this in, what, 48 kilohertz, I think? So that's a no-go for that. Whoops. But I also noticed some other things with the audio. I'm going to show you that right now here. So let me go back. Just stop. I need you going in the background. Actually, I can just close that here. So if I go over to the raw tapes, so I recorded them directly into into Audacity. So this is the one from me. Which one is this? I think this is the one with the bad. Yeah, this is at 48 kilohertz. The issue is still here though. So I'm going to split this into 2 mono tracks. We're gonna basically ignore the recorded audio portion of it. So this is the full tape here. I'm going to turn on spectrogram. And I'm gonna go over and open up 11. Yeah. I'm going to do the same thing. I'm going to split this, get that kind of out of the way, make this a bit bigger, and bring up the spectrogram again. Now, there are some differences between these two. Let's get these. So it looks like the piss poor recording has a high pass filter on it, or the higher frequencies are chopped out of it, whereas the recording which I can actually get something out of has those intact. I suspect that's part of it, not helping. I don't know. I suspect that has something to do with it. That'd be a low pass filter. Oh, yes. Okay. Yeah. I got them reversed. Right. I'm surprised the bitrate matters. I think Messin would take care of all that. No, Messin doesn't do any processing with the audio whatsoever. It is these ROMs are pre-processed. So the recorded audio is the only actual audio. The top track here, that's the only actual audio in the .StudyBox file. All the stuff down here is already decoded into binary. Hey, by the way, just some guy, welcome. So Messin doesn't have to try and re-decode this directly out of audio. Stream and start us on. Oh no! And if I say hello and welcome. So there's a program that Sour wrote that goes and decodes this stuff. I'm not using that version of it because that version is broken. And this program expects very specific values for things. It's got crap hard coded in it. I might try and figure out some stuff with this. Some more generic audio handling stuff. Because I want to re-implement this. And I want to unhard code some things. Like audio bitrate for one. I want to be able to pass in a variety and just be able to calculate. All right, I need this many samples then, kind of thing, right? Whereas for this, it's like hard coded into the program here. But I need to figure out a bunch of stuff specific to WAV files and all that, which we might be doing later tonight. I don't know yet. We'll see. Yeah, and there's some math. I don't even, what the hell? Oh, this is the clock stuff. Yeah, so I gotta figure out what's going on here. Yeah, this is determining the clock and figuring that stuff out. So there's a lot in this that I think we can probably improve. Steve, how you doing? Welcome. In fact, I'm kind of curious actually. So hang on. Is that rewound all the way? Yeah. Let's see if the hardware can actually handle this. I don't think I've tried in a while for this. So this is the duplicate recording of this stuff, right? Because I recorded all the originals onto secondary tapes just so I don't wear out the original tapes doing a bunch of shit or accidentally break them or what have you. Pop that in there. And if it doesn't work in this one, I'm actually going to try with my other StudyBox, because I do have 2 of them. All right, let's turn that on. Let's turn that on. Is that gonna come up, please? No. Okay, I need power. Oh, I need to plug in the other power. Hang on, give me a second. Just the name StudyBox. Box you study from. This one here. Okay. Alright. Now I'm gonna try it. Ha! Turned on that time. Okay. We're gonna go ahead and turn. Well, we'll just go over to this one real quick. Didn't even try anything. Okay. It's having a hard time moving the tape. Which is why it's not giving a number there, by the way. Oh. There we go. Okay. Gonna hit A. Can you hear? Is that picked up on stream? Can you hear that? Yeah. Oh no, I haven't muted. Turn it down. Repeating? Not quite. It's a held note. Yeah, I'll turn it up for you. You hear that? Yeah, I'm gonna mute that for you for now. The tape's still spinning. Turn this down, oh, Jesus. Oh, did it stop? Not having a good time. It's still trying something. There sounds more held. Yeah. The mic probably kind of wavers up and down, probably to some noise filter. But yeah, it's filtering. Good luck, suckers. Yeah. It's doing a bunch of seeking. I don't like that. So while this, I need to mute this. While this tries, I'm gonna dig out my other one. Hang on. Oh, shoot! Look at it go! Oh, my God! Let's go! English, yeah. I do have another one right here. We'll put this down now, I guess. I don't think it's gotten this far before these the secondhand tapes. Yeah, you can see the artifacts in there still too. Goodness. No. That's 1A for a few seconds before this popped up. Not sure that that's normal. Yeah, I think so. Yeah. Okay, so the device can read the tape. Which means I should be able to make software that does the same thing and handles that recording of it.
Hello.
You'd think.
Hello. Hello.
Let me
Hello. Hello.
get this. Properties, not that. Cancel. Audio
I'm
properties.
Akira. I'm Akira.
What is monitor? Do I not
What's
have it?
your name? What's your name? I'm Arnie. I'm
I can
Arnie.
barely hear it through my speakers. No, I'll just use
It's
the TV.
nice
Fine.
to meet you. It's nice to meet you. Oh, it's
Nice to meet you too.
too.
But yeah, the artifacts are on hardware. You can see them flashing. Look at that. Look at that. This is on hardware. This is not emulator stuff. This is on hardware. A little glitchier? No, this is extremely glitchy. Maybe it comes over a little better with the recording because it's a different capture pipeline. Next page. I don't think I've ever been able to get through an entire tape on hardware though. Oh, you can look at Johnny. Look at how bad like he's like compressing and expanding here. Because there's like 2 sets of sprites going on, right? Yeah. So the capture is 30 FPS interlaced. So that probably has something to do with it, you know. And there's some upscaling bullshit and whatever, but
Hello, I'm Momo
Yeah.
Taro.
But yeah, so this works on hardware from this tape. So I should be able to decode that quality of audio, right? Wrong mouse. I should be able to decode this. So I need to figure out how.
Hello, I'm called Monkey.
Oh, it's horribly desynced on hardware. Oh my god.
I'm Momo Taro. It's nice to meet you.
So there's one spot where
It's nice to meet you.
there's another character that goes across screen, right? And it's like on a plane or a jet or some shit, right? Right? And in the emulator, it's very desynced. Do you like my hat? No, I don't! I wonder how bad it is here. So it's in a little bit.
Hello, I'm called Dog.
Whoa! I think the desync is worse on hardware. My god.
Taro. It's nice to meet you.
Like it's running like the audio too slow, you know? I wonder if it'll cut off some of the audio at the end. When you dub the tape, can you record? Yeah, it's stereo. So, you know, that's how it all happens. So one of them is on the right channel, the other's on the left channel.
Momo Taro. It's nice to meet you.
Yeah, the recorded audio is on the left channel and the data is on the right. So if I were to just pop this into my tape deck, you'd hear them both at the same time.
What's your name?
Oh, you saw the character go across.
I'm Momo
Yep.
Taro.
That's like what, a second or two delay?
I'm called Dog. ニックネームなんかの時に使えそうね。
So that's about the same as emulation. In theory, they shouldn't be desynced unless they work. Yeah, unless it was an issue in the master, which I don't doubt, honestly, because I redid this one again, right? And I don't know, it looked like the quality for a lot of the stuff for the first tape was a lot lower than the later tapes, right? Because we went through all of them. I mean, we went and recorded. Oh, you can't even see them. We went and recorded like 11 and 12 on stream, right?
I'm Johnny.
So they had found their stride at that point. They figured out how to do the stuff. This here, I guess they were still like figuring that stuff out, maybe. I'm gonna see how far I can get with this on hardware because I don't think I've ever gotten to the end of a tape on hardware. Hello. I'm Kazuko Koike. It's nice to meet. Nope. What's your name? I'm Johnny. It's nice to meet you. Hi, Johnny. Ba-da-ba.
自分の名前言えるようになったかしら
So we should see this flash here in a second.
Hello, I'm Kazuko Koike.
Because it like
What's
scrolls
your
up,
name?
right?
What's your name? さすが、もう英語で自分の名前が
No?
言えるじゃない？親しい友達と出会った時は、
Huh.
Hello でもいいんだけど、
Maybe I
も
blinked the
かっこ
wrong
よくて
time.
いいのよ。それからさようならを言う時は知ってるかしら？
That scroll didn't look as smooth as I thought it should be.
Goodbye.
But,
そ
alright.
してまた明日会おうねっていうのは See you tomorrow 覚えておいてね。はい、Goodbye. See you tomorrow.
Hi, goodbye. See you tomorrow. Hi, goodbye.
Hi, goodbye.
If the hardware is having trouble with this longer tape, making it run slower, then I can see some decent happening mid-animation. I don't know how it works correctly, but then it should reset between animations. Right. Right.
じゃあ力試しをしましょう。Brother Chance のアキラが仲良し
Brother
な兄に
Chance
会った後、知らない女の子に出会います。正しいと思う言葉を順に選んで会話をしてください。
Is that? Turning up on my side a little bit. What is? Look at that. Oh God, I forgot about these. Hi. Goodbye. See you tomorrow. Can you guys hear this, by the way? Like, I need to turn up a little. I think I need to turn up a little bit. Okay. Hello. What's your name? Nice to meet you. Right. Strobing it out of existence. Oh my goodness. So bad. So bad. Yeah, we don't need that again. Next page. Yeah, I can hear the data bleed into the audio
す
output.
ごい。もう英語で自分の名前が言えるし、挨拶もできるわね。兄弟やお友達にも教えてあげて練習してみてね。See you next time.
Hair looks a lot bluer on the TV. That doesn't explain the same desync happening in the emulator where there isn't any bad hardware to deal with. Yeah, it could very well just be poor mastering of the tape. I did hit next, right? It's fast forwarding a lot. I don't know if I like this. This might be where it ends. I don't know. I did hit next page, right? Not redo. What page was this? Let me come back over to here and turn on this little guy. Oh, it's going. Wait a minute. Oh shit, it's going.
家族を紹介できるようになろう。
Sorry, I doubted you. Maybe you're giving this part too much credit. What, for being synced up correctly? Probably, honestly. Yeah. Hearing the data come through the speakers, by the way, is kind of useful. Because I know the tape's going. The tape's still trying. Jeez. Boom, 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 boom. Boom, boom. See, going to 64 style, yeah. Oh yeah, so I got further in this tape. I don't think I've gotten. I'd rather I haven't. I hadn't gotten past a certain part in this tape for the gold tomahawk stuff, right? See, each of these tapes are divided up with the first part is this bullshit, right? Then there's like a mid-tape quiz, and then it goes on to the gold tomahawk story that progresses along the tapes. And then there's another end tape quiz. For this one, I got stuck, right? Because I couldn't figure out what the hell to do, essentially. I found out what I needed to do, and I got past it. And it's hilarious. So, turn it down a little bit. You basically have to you have to talk to 2 foreigners out on the streets. And then you go into a hotel, and you find a 3rd foreigner, and he's like, "You want to come with me to America?" Huh? That's what you open with? The kid's like, "Yeah, sure, why not? Let's go." Okay. Maybe that was more acceptable back then. I don't know.
Aka Oni, this is my brother.
Thank you.
Who is this?
Ow.
This is my brother.
And this is where I recognize the mountain from, too. By the way.
Who is this?
Who is this? This is Momotaro. Momotaro?
Momotaro, help!
Momotaro, please help me.
Why are they panicking now? Why do they do that?
この人は誰ですかっていうのは英語で何て言うかもうわかりましたね。はい、言ってみてください。もう一度。
As far as I know, the whole stranger danger thing was purely an American thing.
よくできました。
Yeah, I guess.
ですね。それから兄弟のことは
Still, it comes off a little weird of like, you meet a foreigner and he goes, "Yeah, I'm going back to America tomorrow. You want to come?"
sister
Huh?
と言います。じゃあそ
And
れ
the kid's like, "Yeah, sure, maybe."
なんて言うんでしょう。
And the guy shows up at the kid's house, introduces himself to the parents, has dinner.
家族の写真に英語
You see it through the window. It's pretty funny. You see like from outside where they're sitting at the table. And they get on a plane eventually, I guess. I don't know. I guess this is what one of the later tapes is, right? The family stuff where they're all getting on the plane. Was it the second or third tape, I think? I don't remember. Oh, there it goes. Oh, maybe it's this one. Most kidnappings by people who actually know the kid, right? Estranged parents who have been denied custody and the like. Right. Not exactly, a random stranger. This might be one of the very few times where the cursor is not an arrow and it's Johnny instead. Gramps. Brother. Still, Mr. Johnson, how long have you been a kidnapper? Yeah. Father. God, the guy's name that you look for starts with a J. James, I think? Gotta find him.
sister brother
I'll be honest, I'm surprised it's actually getting this far on hardware. On a non-original tape.
father grandmother
It's promising. It's promising.
grandfather
Next page. I like that background pattern too. It's nice. Come on, you can do it. Come on. I don't want to break out the other one.
どう
Oh yeah, this is the plain one.
わかったかしら実はさっきのアルバムの写真
Whoa, look at that banding on the bottom of that plane. Not as bad on the TV, but it's pretty bad on the capture. It looks like a rainbow.
飛行機は係の人に英語で家族のことをちゃんと紹介できないと乗せてもらえない決まりなんですってどうしよう助けてね
Grandmother. It's pretty bad. Yeah, it's pretty bad. No. They didn't go into FM, and that's fairly resilient to a certain amount of distortion. Right. But the decoder that we currently have from Sour doesn't account for a lot of that. So, are there any like MFM decoders that we can just use like out of the box? Not completely consistent. Move sometimes. What is this? Mother? Yeah. Okay. Yeah, I think that might just be an artifact of the capture, honestly, with it moving. The capture and the sync with the NTSC signal. Sister. That's all of them, right? Or is one more? Nope. Cramps. And then Johnny sneaks his way in. Well, I say sneaks, but I think he sprints. There he goes. What's the answers to this this stuff? Workbooks. Raw lesson 1.
Thank you どうもありがとうおかげで無事出発できたわお土産買ってくるから楽しみにしててね See you soon
See you soon. Next page. Because it's when they know, they feel safe, not realizing what is actually going on. Right. What's that with the 8 down there? Is that the page 8? Oh yeah, the end of page 8. Got it. Because the next one, the midterm is number 9. Next page. Uh-oh. Uh-oh, it ain't moving anymore. An AVR assembly. I don't know if that's going to help me. He's got a picture of a breadboard up top. Oh, that's a floppy drive. I know you can't see what I'm looking at, but... I don't think it's gonna help me very much. I don't think. Maybe. Yeah, that's soft locked. It ain't going nowhere. Reload. Let's see if we can get back to that page. Page what? 9? 9. No? Come on. You bastard. Come on. Whenever I reset it, it rewinds and tries to seek again. Come on. You got this. All right. Page 9. That's the you can't see what I'm looking at here. That is this right here. The test stuff. Let's see if it gets there. JavaScript, no. Hard disk dumper. Oh. May have found it. Oh, there it goes. Good.
チェックテスト。さあ、
Okay.
体試しだよ。まずはヒアリング問題に挑戦。テキストの準備ができたら A ボタンを押して
Go back to this. A lot of stopping and restarting the tape in this area.
What's your name? と聞かれたら何と答えたらいいでしょう。これから2回繰り返して言いますからよく聞いて選びましょう。1 Hello Hello
Checked.
2
Not quite.
Nice
Not
to
quite.
meet you. It's nice to meet you. 3 I'm Akira.
I'm Akira.
問い2 Who is this? と聞かれたら
Who is this?
何と答えたらいいでしょう。これから2回繰り返して言いますからよく聞いて選びましょう。1 Thank you Thank you 2 This is my sister This is my sister
My sister.
3 See you tomorrow See you tomorrow
The check test. That one's a bit more related to what I do in my day job, that's for sure.
次はテキストの問題に挑戦。テキストの問題が終わったら
Based on the intro of that page, I suspect there's a little MFM decoding software out there, as it sounds like it's meant to be hardware decoded. Which is unfortunate, you know? All right, so we got 3, 2, 3, 1, 2, 3, 1, 3, 1, and 1. Let's see how we did. Next page. It's not like I've looked for. There's certainly other niche stuff. Yeah, so I mean, there's probably stuff out there for it.
間違ったところは
I mean, there was stuff for
考え方をよく読んで
what's it?
口の方ね
Like floppies and shit, right? Okay, what is this? Movable feast machine? That's not what I know. Next page. Hey, let me do all this over here. Why are the two cigarettes kissing? I think there were two pencils. As to why they were kissing, I can't tell you that. I can't answer that for you. I don't know. I don't know. I'm sorry.
ゴースト魔法第1話不思議な壺
What is this?
この不思議な物語の主人公はたけし君英語を習い始めたばかりの普通の小学生です性格は
Nope,
頼ま
that
れ
ain't
た
what I
ら
want at all.
は言えないお人よしのいい子でもいざという時にちょっと弱虫になることもある
The main question will be whether there's anything that's generic enough that you can easily reuse it for this. Will be the all the stuff out there is more specialized to whatever the author wanted to do.
本場の大リーグを見るんだと張り切っています
Probably, yeah.
今日もスタディボックスで覚えたばかりの歌を歌い
And
な
from
がら
parse it.
や
And then
ってみ
there's
ました
informal implementation. No, it's not. It's a license and a readme. This is not anything. What are you on about?
I'm Takeshi. I'm Takeshi. What's your name? I'm Takeshi. I'm Takeshi. What's your name? What's your name?
VST? You can make music with it.
I'm Little Mary. What's your name?
なんだこいつ
What's your
I
name?
love that line. なんだこいつ?
ただ歌を思い出せばいいんだ
The fuck is this?
I'm Takeshi.
Who the hell are you?
It's nice.
How'd you get in here? Who let you in?
偉いわ。あんたここで挨拶ができるわ。では、
Oh.
教えてあげましょう。明日の日曜日、この町にたけしのことをしているアメリカ
I just noticed the path there. Move, 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 move.
もし出会えたら夕食に招待してあげてね。とアメリカ
Unfortunately, both of these sound more like they're encoders other than decoders. Well, the VSTs, yeah. Yeah. I guess I'll probably have to implement something on my own. Filter. Yeah, we'll believe her. I think that's what that says. Do you want to believe her? Yes or no? Sure. Well, yeah, sure.
リトル・メアリーの言うことを信じて頭文字 J のアメリカ人を探すことにしたたけし君うまく出会うことができるかしらさあ君が手伝ってあげてねたけし
Parents for
君を
drive.
我々のアメリカに連れて行ってあげて
Cylinder head. Okay, yes. This is all like hard drive stuff. Oh Jesus! If it's this or this or this, oh my God! Oh God! That reminds me of work bullshit. Oh God! Oh shit! This is that. Okay, so this here, I've gotta talk to this guy in English. Let me hang on. Let me TV, because I can't pause this. Hello. I'm Takeshi. What's your name? Kent. We don't want Kent. Oh, we can talk to the cat. The cat's like, huh? 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 No, I'll talk to the cat. Talk to this lady. Get over here, lady. Talk to this one. Mary, I think her name is or something like that, right? Hello. What's your name? I forgot to turn that off. I never changed in streamer mode. That's correct. Yeah, look at you go. Oh yeah, I missed her name. It doesn't matter. Cowboy, how you doing? Hello. So now I can go into here.
He's the most powerful hacker of all time.
なかなか
There it goes.
ないわね
61 months. Goodness gracious.
会えると思うのそんな気
Thank
が
you
す
for
る
that. Appreciate it.
もう一息だから頑張
How you doing? How's your week? We're doing this on. This is on hardware, by the way. I'm gonna see how far I can get on the hardware with a non-original tape. Just to prove the point that like the tape is good. The one I'm trying to decode from, and we might go back and see if we can write a decoder or start getting there. You know. And this is the guy. Look how fast we go. This is the guy I want to talk to right here. I had to make up some hours today for work. Time calculation. I got tired. Told to do today. End of the contract. Oh yeah. Okay. Hello. I'm Takeshi. What is your name? James, I think is this guy name. James. There he is. That's what we wanted. Suru. Yeah, that guy.
Hello, I'm Takeshi.
Hello.
What's your name?
My name is James. Oh, I've heard about you, Takeshi. It's nice to meet you.
Can you hear that?
Nice to meet you too.
ジェームズさん、確かに
Turn
頭
that a little
文
bit.
字は
I don't know if you heard that or
間
not.
違いないみたい。さあ、あともう一息。今度は夕食の時
Very effeminate
英語
voice.
でお父さんとお母さんをジェームズに
Oh, I've
紹介し
heard
ま
about
しょう
you.
でも
Excuse?
大丈夫かしら
Not the right tone, I don't think, but. See, I hadn't gotten this far before in the previous record. I ran out of time instead. Where are you going? Why are you rewinding so much? Might break here. I don't know. Did it break? Yep. It broke again. Doesn't know where it is. All right. What's the page I want to be at? Oh. Oh, that's all of it. Oh my God. So it goes from 10 to 12. 10 is the beginning of the sequence. We're going to try to go to 11. We're going to see if that works. Come on. Really? There we go. Okay. Okay. All right. Page 11. Go. His tone is a little weird. A little questionable tone. I can play the recording here in a bit, but. Bunch of seeking back and forth. It's taking longer than the last time. Last time it was at like what, 75, I think. What exactly do you want to do with the decoding? Make your own audio to StudyBox converter. Yes, one that's a little bit more robust than what Sour has. Because we are seeing that this tape does work poorly, but it does work. By searching the start of the page, I think it's finding the next page in a direction and seeing if it's greater, less than, or equal to it. And if it's one of those, it, you know, does its thing. I think. It had to stop. It gave up. It gave up. Gave up. Okay. I'm gonna try 11 again. Go. No, the count, yeah, it just overflows, I think. The tape isn't going at a consistent rate either. So, to much of the time of the audio and the handle, there being several separately encoded blocks and such. Yeah. 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 Yeah, it stopped again. All right, so it won't get that far then. I think it's having trouble with seeking on the tape. It kept speeding up and slowing down. It looks like when it's trying to read the actual data off the tape, it's kind of like right. So it's not going at a constant speed kind of thing, which I think it would need to be going at. You'd think. Yeah. Anyway, let's go ahead and play on that. Let's hide that again. All right, so we confirmed that the tape mostly works. Let's go. Intro. Let's look at this one. Find that. So you probably either need a library with robust enough details or just code that you can mess with and add to what you need. Yeah. Later may or may not be easy to write your own or use the code you already have. You're allowed to modify copy that. I mean, I am. It's on GitHub. I mean, he's archived it, so he's not making any changes to the thing. So I think I'd have to fork that specifically. That it's all in C#. I'm not as comfortable with C# as I am in Go. So I think I'll try some generic audio stuff in Go first, and then see if I can extract out like just the data track, and then extract out just the audio track, that kind of stuff, right? Yeah. So let's put that over here for now. Minimize that. Minimize that. You have to rewrite, convert it to Go anyway. Right. Yeah, this is. I mean, I could modify the C# and compile it here and all that kind of crap, but I don't want to, because I want to understand a lot of this, right? And if I'm just modifying what someone else wrote, I'm not really understanding what's going on, really, right? But if I re-implement it, I have to be able to understand it to make it work, right? I don't know. Anyway, to that end, I found this the other day. Oh, okay, if you can you just, thank you. This is a big ol' audio set of libraries, actually. Paste and go. So wave, MIDI, AF, audio. So this one is a bunch of generic stuff to work with all kinds of audio crap. And then there's some stuff that's specific to wave. So we're gonna have a look at this. See if we can decode one of the two channels. Save that out separately first. Yeah. Yeah, I don't need to interact with the OS really, other than open file. So, yeah, read file, give me file. Okay, thank you, OS. Go away now. Here, OS, write this file. Thanks. Bye. That's the extent of what I'm going to be doing on the OS level. Because I don't want to be dealing with the audio subsystem at all. All right. No. Oh, ugh. Okay, I wanted this window. 'Cause that's what this stuff is right here. Right. So this is all I've done so far. This was a day or so ago. Is just make sure I could read the audio file, the raw wave file, and print out some information about it. Number of channels, sample rate, duration, so on and so forth. Yeah, so we got channels, 2 channels, sample rate, 41.1K, duration, half an hour. That's before the seek to the PCM. This is the seek to PCM, and then the length there. So that is, I think, the number of samples or something. I don't know. What the hell is that actually? What PCM length? The PCM length. I don't know what that really equates to, honestly. All right, so let me back up a hot minute. So we give it a decoder, right? Read seeker, and for that I'm reading the entire thing into raw bytes, and I'm wrapping that in a reader just so I don't have to go down to the disk for all this crap. It's faster that way by a lot. And then from there, let's see. I'm getting the PCM, or I'm trying to get the PCM length here. Oh, it's the number of bytes. Okay, so this divided by 2 should be the number of samples right here. Because this is 16-bit. Yeah, source bit depth 16. So 304487272 divided by 2 equals 15. Yes. Okay. That's our length. Okay, that checks out. This is just the raw sample data, by the way. In what the hell is that in, actually? Len data. Where is data? Data. Duration. Where do I? Oh, down here. That's why I didn't see it. Buffer.data. Okay, full PCM buffer. So that's decoder full PCM buffer. That is nope. This right here. So we don't have to fill a buffer, do stuff with that buffer. We just get the entire goddamn buffer, right? We've already got it in memory, so why the hell not? And that is an audio int buffer. So it's just a bunch of ints. That's all that is. Right. So I guess in theory, so if I take the length of that, divide it in half, is the first half of that one of the channels and the second half of that the other channel? Is that how that works? I don't know. We're going to find out. All right, so let's get a encoder so we can write out another file. Audio format. Okay, so write seeker. Maybe the file. Appreciate that. Interleave samples probably. Well, we're going to find out. The even entries is one channel, odd the other. Like I said, we will find out. We can even just like We can even just tell it there's one channel and write out all the data again and see what kind of audio it produces. Let's do that first. Let's actually do that first, because that's no modification to any of the stuff. It's just read it in, change the number of channels, re-encode it, and see how, or rewrite it out and see what happens. So we need a write seeker. So out file error equals os.create output.wav. We want those. Defer out file dot close. And then new encoder. Enc equals wav dot new encoder. Out file. What else? Sample rate. That's going to be. I'm just going to take this right here. That's going to be this. Oops. I want that. Copy that over there. Next is bit depth. Where do I find that? Buffer source bit depth right there. That's what we want. Like that. Number of channels. We're going to do one channel. And then audio format. Okay, where are the formats listed? Is that in here somewhere? Did it give me a signature of like the kind of crap, or is it just an int? God damn it. Oh wait, hang on. If I just read the damn comment. A number indicating the waveformat category of the file, the content of the format-specific fields portion of the FMT chunk, and the interpretation of the waveform data depend on this value. PCM equals 1, i.e. linear quantization. Values other than 1 indicate some form of compression. So just 1 then? I guess just 1. All right. So we're going to pass in 1. I guess. Write the... Oh, I can just give it an audio buffer. Ooh. Okay. But that buffer has the channels, doesn't it? No. Yes, it does. Compression has 2 meters when it goes down it. Yeah. It double the data length if that's encoded in the header. Oh, the I know what you mean. The like the yeah. I don't know. All right, so we have one of these in buffer. I want to clone that one. So out buff is going to be buffer.clone like that. Out buff.format equals. We're going to make a new one of those. This guy here. Audio.format. Right? Yeah. Channels is going to be 1. Sample rate is going to be format.sample rate like that. That is a pointer, right? Look at the wrong thing. Yes, it is. Okay. Bit depth and data are going to be the same. Okay. Enc dot write Can I just write the whole thing at once? Write buffer, then it gives an error back. Bit depth. Do I need to... Oh, well, we'll see. I need to close the encoder. Okay, so I need to close the encoder too. So I'm gonna defer that close like that. I also had a fun email today from my other boss. Hey, I hope you had a great vacation. Here's some work we should have finished yesterday. Have fun. Thanks, boss man. Nothing big, just a new major release. If error is not nil, return error. And let's see what happens. We're gonna run that. That format undefined. What do you mean? What? Huh? How dare? Buffer.clone. Okay, so that's an int buffer, and I cloned that. Dot clone. Yup. Format is right there. What do you mean? As int buffer. How dare you? Undefined audio. Okay, that's fair. That's on me. Audio. They ignore that error. It's not an actual error. All right. Us. We have an output.wav. Let's see what it did. File new. Close out of that. Don't save that. I don't care. And let's go for here. Output wav. What happened to it? Okay, yeah, it's interlaced. Look at that! Look at that mess. Look at that. Whew. Oh, that is disgusting. We are gonna have a listen to this though. We have to. All right, I do have it turned on for you guys too, so it might be a little loud for you. Prepare your ears. Okay. Not what I was expecting. At all. Should sound like both channels at half the original speed. You were right. You knew what to expect. Not me. Boo. Yeah, so it's interlaced then. Okay. So every other sample then? Is that what that is that what I'm Is that what it is? Like every other sample is every other sample? I guess. I don't know. Let's work with that. Let's assume that it's every other sample. So that means we need a new buffer. Let's get an int. Can I just create an int buffer? I mean, why wouldn't I be able to? Yeah, outbuff is not going to be that anymore. Instead, it's just going to be an audio.int buffer. Let's go ahead and format equals that. What else we got? Data. Data is going to be, we're going to make an int. Length of buffer.data divided by 2. And then the, was it sample rate? Source bit depth. That's going to be, oh, I can just pass in the other one. This guy here. That, get rid of that. What do you need to be? No channels equals 2. I want to take out a channel. That's what I'm trying to do. I'm trying to remove one of those channels. I want to isolate a channel. Yeah, okay. So for I0, I less than length int. No. Length out buff dot data. Well, yeah, so times 2 there plus equals 2. Because I'm going to be doing buffer.data at I. No. Out buff at I divided by 2 equals that. Right, I'm using the new buffer's length. Right. Yeah. Although, I mean, I could use the original buffer length. That seems safer for some reason. For I is 0, I is less than length of the buffer.data. I plus equals 2. And then out buff I divided by 2 equals I. No, equals I. Buffer.data at I. Why do I think that... That's the same exact goddamn thing I was doing. When I iterate over the original buffer anyways? I mean, I am. I pre-allocated the whole buffer that I'm going to. So I can't do... Well... I can't do the append, right? They have not replaced me yet. Omnifidus. Omnifidus. Am I saying that right? Not yet. My boss actually hasn't said anything about AI recently. It's beautiful. At that point, it's better to do plus plus and times 2 on the inputs index. Okay, yeah. Plus plus, and then times 2 like that. Yeah. All right, let's see what this does. Let's see if this breaks. Unexpected new line. Okay, because I didn't put a comma where I should have put a comma. That was all that. What? Stop it. I saved, didn't I? 93. Oh, no. Not the comma. Invalid operation. Cannot index out buff. Because data. There's no way that understands PLB, right? So niche, no one bothers with it. Fuck PLB, by the way. Oh, fuck you. -1. Looping over the input buffer, you need when you're looping over the input buffer, you need plus equals 2 and divided by 2. Yeah, this is the input. I do need it the other way then. Why are you confusing me with all your words? Huh? Why are you doing that? There we go. Okay. All right. Now, let's get rid of this. Let's have another look. Listen. That looks like only one of them. Pause that. Okay. What does this sound like? Come on.
Enjoy English. 1号
All right, we're figuring out audio. Let's go. Okay.
Enjoy English. 1号
Look at it first, but then you didn't read my message. That's you. Yeah.
さあ、ユニット1からスタート。
Okay, good. So now we know how to get all of the data out. So if I start at 1 instead, write it again, watch it crash because of out of bounds or some crap. Now I should just get, oh, it didn't crash, cool. I should just get the data. Beautiful. Beautiful. Let me get the spectrogram. Beautiful. Look at that. Look at that data. Come on, scroll, damn it. Look at that data. Beautiful. Okay, good. All right. I kind of want these. Perfection. Yeah. I think I want them in their own separate audio buffers, just so it'll be a little bit easier to work with, so I don't have to do the interlacing crap or the de-interlacing. Excuse me. If I've looked at Odin, is that a language? Odin programming language. I haven't looked at it. No, I don't think. General programming language with distinct typing built for high performance modern systems and data oriented programming. No, I haven't looked at it. I'm probably not going to look at it tonight, but I'll keep the tab open. Working on it for about 10 years. Wow. All right. Okay, so I'm going to hit play on this again because I don't like not hearing anything. Tobbs, how you doing? Welcome. All right, so let me actually put this in another function so I can get that out of. I can have it garbage collected later. Read input file name strung, and I want two things. I want two audio.int buffers. Right? Int buffer? That's what it is, right? Where's this one? Int buffer, yes. I want two of those. One for each channel and an error. So let's actually just use that. Not as a read, not as a byte or open. Let's do that. File decoder. Grab that. Paste that there. Okay. I don't care about the duration stuff. I do care about the format. We're gonna be getting rid of all this. I don't need that. I don't need that anymore. Full PCM buffer. Yeah, let's grab that and put it up there. Get rid of all that. We're not gonna do that yet. Instead, we're just going to let's see. I don't want to call it audio. Left, right, error. How about that? Equals read input. What did I have as the input name? It's just input name. Okay, got it. Input name. Like that. If error is not nil, return error. Okay. Let's see. Out buff. No, we want left audio dot int buffer. Do some stuff with that, and a right. Actually, let's yoink. Paste that there. Paste it there. Yoink. Yoink. Actually, can I? Left dot clone clone dot as int buffer, like that. Gives me a new one of those. Good. So I set it up once and I clone that before any data's in either one of them. Okay. So this, gonna yoink that, put it there, but I need both of them now. So instead of this, left is going to be, or starting at 0, is going to be this. No, not that. This right here. And then right, left dot data at I divided by 2 dot data I divided by 2 equals buffer dot data I plus 1. That should work, right? Then I want to return left, right, and nil. Glad you don't see it. Don't waste time on it now. All right. Yeah, okay. All right. So we got the 2 buffers. Okay, actually, I'll leave those there for now. We're gonna do 2 files here. Left.wav, and we'll do a right.wav as well. Right file name, string, buff, io int buffer, return error. And this, like, paste that there. Sample rate. What is that? An int? Yeah. No, not an R. I want an S and an S, like that. Buff 1 and 1. And then from there, I just want to do one of these guys here. Yoink. Paste. And just return that instead. Don't have to worry about it. Good. Let's get rid of that. Let's get rid of that. And then just error equals right file. Left.wav. I notice I need to change that file name up there. Give me a second. Sample rate. I could just get that from there. That's going to be buff.format.sample rate, like that, and then I don't need to pass that in. I can just do left and do the same thing for right. Okay. Then up here, I want to put in the file name. Like that. Yeah. From that over has some interesting aspects, but also some stuff that I don't like. It seems only verbose in some aspects. I would like aspects I use often, but I see why they're doing it that way, coming from an interpretation compiling point of view. The new kids on the block use content-sensitive editors, so verbosity is not necessary. God. So the intern. Oh, Toms, I'm sorry, I didn't answer you. What am I working on? I'm working on some audio decoding, some MFM audio decoding, taking data from audio and decoding it into bytes. I'm getting there. I'm not there yet, but I'm getting there. It's all for this StudyBox stuff that I've been working on and off for a few years. Taking data, yes, data. You want to listen to it? It sounds kind of jank. That's what it sounds like. Yeah. So right now, beautiful melody, right? So each audio file and the file. Where the hell did it go? Oh, I'll put it back in here. Comes from, obviously tapes. This is not the original tape. Those are somewhere else. I have some of them. But there are two channels. One of them is recorded audio, someone talking. So if I solo this and pause that.
でもなんでジェームズさんはたけし君のことを知っていたのでしょう。それから
So we got some people talking on one side, and on the other side is the data, that stuff. So right now I am just getting comfortable working with audio programmatically, specifically the wave data. So I'm reading it all in. I was able to isolate out one channel. I am reading it in, splitting it out into two separate files, left and right channels. And then I'll work from there for actually decoding the actual stuff. Diets Land, how you doing? Welcome. Let's go ahead and hit play on that. Yeah, at first I didn't split it at all. I just told it that there was only one audio channel, and then I wrote the data directly back out the disk to see what it would do. Turns out it's interlaced, so every other sample is for the channel. Yeah. Digetsland? No, but I probably don't enunciate very well. Dietsland. Am I saying that right? Or Dietsland? I don't know. How do you break that up? You don't have any capitals. Okay, let's see if this works. Nope. Bytes imported, not used. Okay. I don't return enough stuff here. So, nil, like that. Nil and nil. Nil and nil. More nils. Okay. Bytes no longer used. Undefined out buff. Out buff. Out. No. Buff. There we go. Okay. Dietsland. Okay. Welcome. How you doing? How's your week? There's an alternative by John Blow, who was big in the gaming world. It's called Jai. Not fully open yet. I've heard of Jai. No. Just because I don't like it doesn't mean it is bad. Probably just biased from playing C and Golangs, and that's what I work. Yeah. Oh, this is going for a little bit longer and a little bit harder than I was expecting. Did I do something wrong? Oh, well, okay. So one thing I did. Can't add frames of bit size 0. Huh? Let's, hang on. Read done. Okay. What the hell does that mean? Can't add frames of bit size 0. Error F. Error writing left dot wav. W. Like that. Right dot wav. Not a valid file. Okay, this one. Error F. Full PCM buffer. Ah. Nope. This one, format.error F. Error reading input. All right. Where did that break? Yeah, the read takes forever now because I don't read everything into memory. I'm not sure if there's a scoping mechanism like in Python to give you names without having to specify it, like you wouldn't have in old C++. What, there's no scopes? What? Pretty bad C++ where I just write non-idiomatic C code disguised as C++. Ah! Okay, this decode takes absolutely forever. Oh my god. I wasn't expecting that. Error writing right. Left presumably works fine then. Really? What happens if I grab that, paste it there, rename it right? Also, for reading the input, we're not doing it this way. Raw, read file. We're gonna use bytes again. File equals bytes dot new buffer, new reader, raw. That's what we're doing there. This should speed it up a little bit. Should. Undefined file. Okay. Well, about that. Well, it's right. How? Oh, right. That's right here. See? Look how fast that read happened. Okay, so cloning it broke things. Oh. Cloning it broke things, which... Okay, what does the clone actually do then? Hang on. Like, what's the underlying clone? Copies that. Okay, well, it's a... It just returns itself. Huh. They forgot to copy the source bit. Oh. I see. Good catch. I wonder if they accept pull requests. When was the last commit on this? 6 years ago. I doubt it. Okay, cool. Pull requests. How old are these? 2019. What's with the image? Oh, it's a fucking bot. Oh. Anyway, so that's why that broke. Okay, cool. We're gonna copy the stuff then. Screw it. Yay, code duplication. Woo! Okay, so let's go over to. Nope. Nope. This one. That was that one. Close out of that. Right. And left. Can I copy that? Good. Look at that. Solo.
ようになるのよ。さあ、ユニット
Good. Cool. Okay, so I have both the buffers now. Now what? now I gotta do shit with it. It's being unchanged for a while, so it's on its own, which wouldn't mean much. Not like Wave changes often, but there being old open PRs like that is a less good sign. Yeah. 6 years. The last commit was a merge though. So I mean, it might not be completely out of the question. I don't know. Has this guy done anything on GitHub for a while? Give me his. Can I get to his profile? Thank you. He is very active on GitHub. Okay. 2 contributions today. So who knows? I don't know. Yeah, I'll look at that stuff later. I'll see if I can put together a PR for that. I'll check the other formats too to make sure that they also have that the source bit depth. Yeah. All right. So, what in the hell do I need to actually do now? Give me a second. Nope. We're gonna go over to here. And then over here, and then this one. Bring it over here. So this is basically what I'm re-implementing. This right here. This is Sour's decoder. This guy. Main program. All this does is look for wave files and then sends for each wave file, sends it over to the decoder to decode. Okay. So we're gonna go over to the decoder right here. Decoder takes a wave file. Okay. WAV file equals WAV file. Sure. Wave header size. I don't think I actually need to do a bunch of that crap because I already have the samples. Right? So he's looking at the samples here. He's original samples, getting all the samples. Okay. Right. Okay. So yeah, he's decoding the wave raw. He's not using a library for that, right? Yeah. Okay. It's okay. So I don't have to worry about that because I've already got that part figured out. Okay. So decoder. Yeah, and then not log, but not add bit is clock. No. Apply filter. No. Decode. Right here. Clock type. Last clock type. Clock type dot none. Okay. For I equals 3, I is less than sample's length. Minus 3. What the hell? I'm already... Why 3? Why 3? What? Huh? Ignore 2 clocks in the same direction as in a row. This usually false positive. Seems to be doing himself and in a very hard-coded way, probably not very generic, but specific to the wave files he had. Right. Y3 comment below. Okay, no two clocks in the same direction in a row. This is usually a false positive. Okay. Can I actually hang on? Let me have a look. Nope, not that. Here. Let me actually zoom way the hell in. Like way in. Like way in. Like even more. Right, so these are the samples I'm going to be looking at in the code. Can I... Why... It, like, changes the resolution of the scroll. And it's so fucking annoying. So I'm seeing a pattern here. Is this the clock? That right there? You see that? That right there. Is that the clock or something? Okay, is clock I? Is this looking at every third sample? No. It starts, okay, so it starts 3 samples in. Samples at length. Samples, where is that set? Is that set in the initial load? Yes. First sample count. Samples. Samples ready equals value. Okay, so that's the individual samples then it's looking at. Is clock I. I being... Okay. Where's is clock? Is clock right there. The signal doesn't go up or down at least 500 samples within 3 seconds. What? It can't be a clock. 500 values... If it's not a delta of 500 within 3 samples, it can't be a clock. Is that what that's saying? How to locate? Yeah. So it doesn't go up or down. So I don't like binding this to the sample count. You know, because that binds it to the sample rate. I'd rather bind it to like a millisecond or something, right? Can I do that? I don't think I can. Well, let's get this, I guess, like ported over. I don't want the symbols. Get all symbols, and then can I close out of that? Freaking thank you. I should probably just open this up in Vim on my end. Jeez. This... Clock type is clock. If it's not none and it's not last clock type. So if it's a new clock type, find the gap. If gap is less than 6, ignore this peak, probably a false positive. Ew. The formula gives you the sample rate, so you can calculate the number of samples per millisecond from that. So how would I figure out the number of milliseconds I need? Just by staring at this data? Staring at this? So, okay. Second per sample rate. Second divided by sample rate. 60 divided by sample rate is milliseconds. All right, so... Right? So down here, I'll write those out. Fine. Get rid of that because I don't need those anymore. MS equals... What, 60? divided by. No. That's second, right? 1 over 8. Oh. What is that? The right? Yeah, it's right. Right dot. Format? Where do I... Format, that's number 8. Yep. Yeah. 1,000. Milliseconds. And that is nano. Do I want nano? I probably want nano. What is that? Million? Yeah. $1 million, yeah. Might need to know some details of how MFM works to figure out what you're looking for in terms of peaks, etc. Probably. Wasn't there a didn't Bridgewater write something up for this? Was it StudyBox or firmware? Let's do this one first. Observations on the hardware. Dual-track stereo. Yeah. Data track analysis. We're going. Appears to be during this one. The file is little endian in riff wave. PCM 16-bit stereo, 44.1 kilohertz. Left track is the audio, right is the data. Yep. About 30 seconds of the recording, the data starts containing a wave about that. Let's bring up some encoding data. 23 cycles over about that many samples a cycle. Frequency analysis claims. Okay. Turns out that the data is using 4,800 bit per second MFM encoding, the lowest level. That gives you milliseconds per sample, right? So probably be between 0 and 1 reasonable audio sample rates. You have an audio sample rate of 44K or something, and you probably want to use nanoseconds to have a whole number to work with. Yeah, the whole number would be nice. Yeah, we'll have a look. We'll see if this is more than 0. How about that? Let's just start there. If ms equals 0, return format error f. Nope. Not ns. 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 Yeah, I changed it. Don't worry. 22. What is this again? 22 samples a nanosecond? Is that what that is? How would I use? I don't know how I'd fucking use that though. 22 nanoseconds per sample. Okay. Nanoseconds per sample. I'm gonna write that down so I don't confuse the shit out of myself. Okay. So I'd want what? 66 nanoseconds instead of 3 samples. (22) times 4 for 1. It's close though. Microseconds? Is it? I don't know. I always get them confused. (22.675736961451251246) 22 and a half. Oh. Well, for now, we will use just 3 samples. For now, just because. Where the hell's the code? Where did I put the code? Okay. Goodbye. Oh yeah, it almost certainly has rounding errors. Almost certainly. Actually, not almost. It does. I know it does, because all float shit has rounding errors. Also, you want to include the frequency of the encoding in your calculations, which may make the numbers nicer. That's the sample rate, right? This is right here. I thought. That's the samples. That's the. It's per second, right? Only where the fractional parts is not part of 2. Well, okay, sure. That's the frequency of the audio sampling. I mean, the MFM encoding. Oh. Right. Which would be that. 4,800 bits a second. But then that might not be exact with how, because like the tape could have been slowed or sped up ever so slightly, so it won't be exact, right? It's literally my job. Shut up. This is very well not transitioning more than once per bit, not exceeding the capacity of the tape, or less than once per 2-bit period. So I can take a full 2-bit periods to transition at times. It's spread over 3 bits, meaning that the process of clock recovery is fairly simple. So I need to figure out the clock, essentially, and then once I figure out the clock, I can figure out the actual bits. Right? Modified frequency modulation encoding is isosynchronous. Each bit takes up the same amount of time. Self-clocking, right here. Flux transitions occur at predictable locations and a certain minimum rate. And run length limited. There will never be 2 consecutive half-bit periods with a flux transition. nor will there be more than 4 without. An encoded bit stream looks somewhat like the crude diagram below. Best viewed and affixed with font. Yep. A couple of the features of note: pulse widths vary from 2 to 4 half-bit periods. Pulses transition in the middle of a bit period for a 1. The edge of a bit period for a 0, unless the bit adjoining that edge is a 1. And a row of consecutive 0 bits looks identical to a row of consecutive 1 bits. Uh-huh. You want to figure out how many samples there are per MFM clock in the actual input data, and use that rather than whatever you initially calculated for the sample rate. Right. Right. The leading region for each page, a long string of consecutive 0 bits, terminates in a single 1 bit. Okay. After which we enter the data region. The data region consists of repeated sequences of a 0 bit followed by 8 bits. MSB first. To be read out from that address, all 8 bits in parallel. Because every 9th bit is guaranteed to be a 0, encountering a run of 9 or more consecutive 1 bits means that we are reading the lead-in region and are desynchronized by half a bit. More timing. 4,800 bits per second divided by 9 bits per byte is 533 and 1/3 bytes a second. Or 1 byte every 3,300 clock cycles, give or take. Using a per bit model, that's 1 bit per short. Tape speed variation may cause actual timing to vary somewhat. Okay, so yeah, so I need to find the clock, essentially. Let me hang on. Let's go over to Wikipedia. Modified frequency modulation. Okay. It's a run length limited RL line code used to encode data on most floppy disks and some hard drives. Right, clock data, and then what's AMI? That's not what I thought it would be. Oh, it's like no. No, I'm not the wrong one. First introduced in the 70s, original frequency modulated coding FM could specifically for use of magnetic storage. FM allowed devices to double the speed data. Okay, yeah, sure. Disregards such a very mechanical effects are caused. They cause the original pattern of data to jitter in time. If a long string of 0 are sent to disk, there is nothing to indicate which bit the following one might belong to. Do the effects of sure. Frequency modulation was the first widely used system to perform this operation. The drive controller includes an accurate clock running at half the selected data rate of the disk media. Huh? When the data is read to the disk, the clock signal is interleaved with the data. On reading, the clock signals are used as short-term triggers to time the presence or lack of a following signal that represents the data bits. Huh? Yeah, it's in the encoded data, right. J3Z, how you doing? Welcome. Welcome. Alternate mark inversion. Oh, okay. Different encoding, yeah. The upside of the FM approach is that it is extremely easy to implement the writing circuitry, and the clock recovery on reading is also relatively simple. Okay? The downside is that it uses up half of the disk surface for the clock signal, thus having the total amount of data the disk can store. This led to new forms of encoding that were more efficient. Okay, so yeah, modified frequency. Okay. Modified frequency modulation encodes the clock signal at the data in a single clock window. Okay. Unlike FM, a clock bit is only written when needed to achieve synchronization when both current and preceding bits are not set. I beg your pardon? On average, MFM achieves double the information density of FM. Okay. So I have to check to see if it's a clock bit or if it's a data bit. School bit lower. The next listing help me out. Yeah, I'll get there. Yeah. A byte encoder using FM above and MFM below. Dash blue line denotes a clock pulse. The signal level change in its in it is ignored, and the dashed red line data pulse. Signal level change encodes 1. Absence thereof encodes 0. That's what I thought I should be looking for, right? Where's the change in the state? Which was which again? MFM is on the bottom. Okay. If there's a state change on the clock? No, not quite. Okay. The basic encoding rule for MFM is that XYZ encodes to XX nor YY, Y nor ZZ. What? A 0 bit is encoded as 10 if preceded by a 0 bit in the input stream, and as 00 is preceded by a 1. The 1 bit is always encoded as 01. The number of magnetic transitions per 1 bit of encoded data is on average 0.75 to 1. What's a longer example? Yeah. This guy here. Note that the surrounding clock bits are sometimes known, but sometimes require knowledge of the adjacent data bits. A longer example. Data 000111011. Encoded. Oh. Okay. The clock, unknown. 110000. FM encoded. Bold bits are the data bits, the others are the clock bits. In encoding, the number of 0 bits that may appear between consecutive 1 bits is either a 0 or a 1. In encoding, there is a minimum of 1 0 bit between adjacent ones. Okay. Because the MFM system requires more accurate timing of the clock signal, it is not possible economically to build the required analog and digital components in a single integrated circuit. I don't care. Instead, MFM drivers required one drive entered the data separated. Sure. Overall format. FM and MFM are used to indicate position of individual bits in the original data, but the data does not in itself have any higher level of organization like files. Sure. This is the purpose of the format of the disk. Disks are typically formatted into fixed size sectors, which contain additional header information. Short. In the IBM format, the start of the sector's header information and the start of the data itself are indicated with a special sync mark pattern of zeros and ones. So that's the lead-in stuff that we're looking at here. Then the data lead-in, right? Lead-in reader for the page, a long string of consecutive 0 bits terminates on a single 1 bit. That's that lead-in thing that's IBM does different. All right, MMFM. I don't care about that. Okay, so references for the reading. References. Forensic computing. Choosing a hard disk. How dare. Can I read the full text here? There it is. Oh my god. Ah. Whoo. PDF. Just give me the goddamn PDF. Why do I have to... I'm not doing this. All right, so So I understand it in terms of the bits here. I'm not entirely clear yet on how to translate the wave data, the raw sample data, to that, right? So I can see in here, if I zoom out a little bit, I can see variations in things, right? So let's go to the very beginning. I want to find that lead in. Where is that lead in? Oh. So this is that lead in right here. 30 seconds. Not quite. Okay. Here? No, this is where I start. There's the lead in right there. Okay. Reading that right, a long string of zeros will give a very clean clock signal. At half the speed you need, at half the speed you need to read the actual data. As far as I can see, every other bit is the value of the clock. Right, based on that you can decode the data. Right. What I'm getting at though is I'm reading the raw values of this shit right here. Right? The raw samples of the audio. I need to be able to take this and get the clock data out of that, right? So figuring out like the peak, the low peak and the high peak, right? Where those are. Figuring out how many samples are in between those, right? Maybe? So then, like, right here's a bit. Ah, I didn't want to play it! Oh, my God. Jesus, I lost where I was. God damn it. God damn it! But yeah, so this is very clean right here. Son of a bitch. Maybe I should just like trim it down to like one page. Let me let me do that real quick. Hang on. Let me trim it down. Let's go like 5 minutes. Get rid of that. Same thing down here. Just get rid of. All that. And actually, I can just get rid of that too. I don't need that right now. You have the frequency of the audio channel, don't you? The frequency is static. At least it seems that way. Is it? I have the frequency of the recording. This right here, which is 44.1 kilohertz. 22 dot something microsecond be the duration between the peaks and the lows. Should it? So can I get a I don't have like a this is X amount of microseconds. Wasn't it 22.6 equals the time for each sample? Maybe. I don't know how to see how much length and end of selection length, etc. Start and length of selection. It doesn't even give me... It doesn't go down that far! Ah! Time per sample, yeah. So would that be this right here? Would I have highlighted anyway? I don't know. But yeah, so he was so the way Sour was doing stuff, right? Over here. He's looking at the is clock, right? Where's that? Is clock. So he's looking at this sample and the 3 samples prior. So he's looking at like this guy, right? So like, yeah, that guy down to 1, 2, 3 there. So from this one to that one. See if that's more than 500 essentially. So that famous last words shouldn't be an issue. I don't know about that. I kind of want to get a quick recording of the same tape at 48 kilohertz, just to compare. 5 minutes. I don't need 5 minutes though. I can do like a minute. It's fair to say within this very short area, yes, but remember that 1, this is the lead-in, all zeros, and 2, tape wow is a thing that we'll probably need to handle. Yes. That's what Sours does not handle is any variation in the speed of the tape. The wow, right? And I don't know, I thought just looking at this I could see a little bit of that. I don't know, maybe I'm imagining things, but I thought when I was looking at it earlier. Maybe I'm imagining things. Wow, wee wah. Yeah. Anyway, let me get a minute and some of recording of that. So you don't need to hear. You don't need to hear that. I kind of want to hear it though. I'm gonna turn that way down for me. File new. Do it with a new one. We're at 48. We're gonna hit play. I'm gonna hit that and then record. I didn't mute myself, right? Okay, good. I have my mic going through the same channel, so I need to turn my mic off for my computer. Come on, where is it? There it is. Ichigo. Enjoy English. Ichigo. All right, I'm gonna get up to yeah, after the first one. You can scroll all the way again. Sour seems to analyze 7 data points in total. 1 he's looking at, and 3 before and after. Okay. Yeah, I'll have a look at that in a second. Can you hear that through my speakers, by the way? I've got to play through my speakers. Barely. He inspects 3. The one he's looking at. And the before and 3 after. All right. And I think there's a smaller one right here, right? There's this one, and then right after this one, I'll stop it. That way you can look at the, look if it's a local maximum or minimum and how the trend looks. All right, waiting for the cutout. There it is. Stop. Stop. Rewind that. Okay. We're gonna split. Delete that one. And scroll a little bit. Whew, look at that. Look at that wave like that, right there, though. Yeah, you can't hear the difference. What is going on there? What is going on there? That's still in the lead-in. Like, this is a dirty, disgusting signal. Look at this. Look at how nasty that is. That's horrid. That's terrible. Is it all 7? I should read the whole piece of code. Yeah. Let me actually let me get back to let me go in and read more of the code. I wasn't actually doing that. Okay. Oh, I turn my music way down on my end. Is music still there? No, because I didn't unpause it. Fluxstorm, how you doing? We're figuring out some audio decoding. Getting data out of audio. Okay, so. Plus and minus 3. Okay. If the signal doesn't go up or down in at least 500 samples, up or down at least 500 values within 3 samples, this can't be a clock. Okay. If the signal doesn't go down, if the signal doesn't go the same direction on both sides, it can't be a clock. Mass sign, sign. Mass sign. Okay, it's checking the direction of it. All right. Sound waves. Yeah. In ways that are disgusting. That's that little dip right there. This is all encoding a bunch of zeros at this point right here, right? This is the lead-in to a bunch of data. It's encoding 0. Why is there a dip? What's going on with this dip here? That dip shouldn't be there. The data actually starts like right there. So, sentiment analysis on audio clips a while back sounds hard. Sound is hard, yeah. So what I'm doing is not like, I'm not like building a filter or that kind of stuff. I am taking digital data out of an audio wave, essentially, right? So this is what it sounds like. You want to hear it? You ready? Plug your ears. Okay. That's what it sounds like. So that's all data. And I want to extract said data into raw binary. Now, easier said than done, I think, especially because I don't necessarily fully understand the process for it. I get it at like a higher level, kind of, but the actual implementation of it is, I don't know. Tape dropout? Yeah. This is a recording from tape and a copied tape at that. System noise and variability is to be expected, right? If it's positive and it's negative, also positive, aren't we in the middle of the rise and not the peak? I guess. Yeah. The sample doesn't go in the same direction both sides. It can't be the clock. Because the clock is actually changes, right? So hang on, let's go back to the diagram in here. Well, That doesn't make any sense. Isn't the check wrong? His code, you're saying? Possibly. I don't know. I'm not sure I fully understand MFM yet. All right. Let's hit play on this because I don't want to listen to nothing. Okay. The current sample, if it is greater than or equal to the previous sample, and it is greater than or equal to the next sample, we found the peak. And the previous sample is greater than the sample before it, and the next sample is also greater than the sample after it. That's disgusting. I see what he's doing here, and I don't like it. Because that seems so dirty for that, right? You're only checking a handful of samples. Yeah, gnarly way. Yeah. You're only checking a handful of samples. So yeah, you're bound to the sample rate that... Yeah, you're bound to 44.1 kilohertz doing it this way. Whoa. Super clear, yeah. Not to me. Yeah. To be in the rise, we need to sign that. Notice the last one is swapped around. Yeah, this one's swapped around, right? To get the low. One, two. One. This one, that one. Oh. And this is basically the exact opposite of this guy up here. Otherwise, it returns. Nope, not a clock. The sign check above that. Oh, this here. Yeah, so it's checking like this operation of this sample minus 3 samples ago. If the positive or negative of that is equal to this sample minus a sample in 3. Yeah. I see. I'm not familiar with that abbreviation. Anyway, I need to take a piss real quick. I'll be right back. Don't go down. I'll be right back. Okay. The check is correct, my bet. It has drawn by hand. This is fine. It's written confusingly but correctly. Oh boy, what? You take a picture we wrote out. All right. 1, 2, 3, 4. What? I is 5. Oh, that's amplitude. 5 amplitude. I minus 3 is 2. Okay. I plus 3. Say it's 3. If plus is not equal to plus. False. Hence it's a clock. I'll put that right over here. I think that's still going. I think I'm still a moron. Not gonna lie. Go to hold Excel draw. Excel draw. Excalcul. Like, shut up. All right. Well, so we'll get back to that in a second. All right. If clock type is none, and it's not in the previous clock type, huh? If the clock type is not none and is not the previous clock type, time gap equals. Oh, so okay. So if the clock type changed, time gap equals I minus last clock. And this is an arbitrary number. MS Paint. Pronounced MS Paint. Gap between clocks too small, ignoring clock. That's that error that I got a lot of somewhere, right? Been debug that output. Not that one. This. Gap too large after 0. Gap 16, gap 20, 16, 20, 16, 20, 20, 16. Samples. Like 16 samples, 20 samples. So that... I think that's because the V2 was 48 kilohertz. So what's this after 0 crap? Too small. If gap is greater than 1,000, try to find another 0 followed by 1 sequence. Okay. So that's finding the next page. I hate how it's in a massive try-catch block. I don't like that either. Oh my god. The amount of level, the indentation, oh my god. The nesting. Holy crap, that's the word I was looking for. Nesting. Retry count. If it's less than 2 and failed or raw data count is greater than 0 and the raw data, 0, is not C5? Oh, that's the actual data. Yeah. Okay, the is clock is valid. The first 2 checks are detecting the magnitude of the oscillation. The third check checks for local maxima minima. And the 4th and 5th check for continuity. Okay. All right. Reset. Apply filter. Oh, God. Last save position, last clock. Continue. Okay, retry count 0, save page I. Seems like this would be a good spot for a fairly complex state machine instead of nesting hell. I don't know yet. If the time gap is greater than 20, gap too large. Fail was true. Okay. Else, last bit is 1, time gap is less than 11, 6 to 10, sample gap 1 1. Add a bit. Else, if time gap is less than 15, 13 to 15, sample gap 1 0 0. All right. Else 16 to 19, sample gap 1 0 1. Okay. Otherwise, if it's a 0, yeah. I bet if not data started. Track lead in, start and length, 0-bit counter plus plus, 0-bit counter, if it's 1, lead in position equals I. Okay. That's getting the past lead in stuff. Else if time gap is left to 15, 30 to 15, sample gap 0-1, add a bit. If not data started. If this is the first 1 bit we find, the next bit should be a 0, and then the first byte starts. Start a new data track at. So I get a bunch of those, don't I? Not in this one. This one, nope. This one I do. Start a new data track. Start a new data track. So this one breaks on one of them and fails the entire thing. And stuff is done in hardware for, yeah. This is all. It's done on hardware on the StudyBox, right? Yeah. PPLs. What is a PPL? Instead of peak detection. I don't know what PPL is though. Phase locked loop. Is that something that could help me here? It's a way to recover a clock frequency. It's a control system that generates an output signal whose phase is fixed relative to the phase of an input signal. Keeping the input and output phase in lockstep also implies keeping the input and output frequencies the same. Thus, a phase-locked loop can also track an input frequency. And by incorporating a frequency divider, PPL can generate a stable frequency that is a multiple of the input frequency. Okay. The properties are used for clock synchronization, demodulation, frequency synthesis, clock multipliers, and signal recovery from a noisy communication channel. Since 1969, a single integrated circuit can provide a complete PPL building block, and nowadays have output frequencies from a fraction of a hertz up to many gigahertz. Wow. Thus, they are widely employed in radio, telecommunications, computers. Yeah. Oh, Jesus. All right. Simple example. A simple analog PPL is an electronic circuit consisting of a variable frequency oscillator, VFO, and a phase detector, and a feedback loop. The oscillator generates a periodic signal, V0, with a frequency proportional to an applied voltage, hence the term voltage-controlled oscillator. Right. The phase detector compares the phase of the VCO's output signal with the phase of the periodic input reference signal, VI, and outputs a voltage stabilized by the filter to adjust the oscillator's frequency to match the phase of VO to the phase of VI. Oh. So if you're willing to build a custom hardware, sure, it could help, but it doesn't really help for writing a pure software solution. It's an analog hardware thing, not a software digital. Damn. No. Excuse me. Where did... Oh, I minimized it. That's what happened to it. All right. Yep, too large after 0. Okay, y'all. Yeah, so I was getting a bunch of these in the 48 kilohertz. Yep. Yep, too large after to 0. Because it was just misaligned. Exception could the two small large gap or is invalid a 0 bit plus 8 data bits pattern. Sure. Data started. Where is that set? Where's that set? Is that set anywhere? I see it checked. Oh, there it is. Data started 2 over here. Okay. God damn. So. Would it make sense to have this in like a 2-step process to decode first the wave into the bits, just the raw bits, and then extract the data out of the data and the clock out of the raw bits? Or to make more sense just to do them both at once, like this one does it? I don't know. Save page. I have to get the bits first. All right. At least from an incremental development point of view, yeah. Yeah. So I guess the first part of that is figuring out if it's a clock. All right, so let's. Can I? Where's? Hang on. Up. Give me that over here. You can look up his peak detection. I don't really think of a better way to do it. Yeah. I'd rather. I don't necessarily like having to hard code in the sample count in there because that. But we can come back to that. All right. We're just gonna do a raw equals decode. Oh, raw and error. Why not? Decode. What is it? Right. Dot. Data. Yeah. Maybe apart from the 500 cents, that seems like a magic number, but hey, no idea if the real world values of the real. Yeah, we'll trial and error. I don't know. All right. Decode. That's going to be data. Samples. That's how it's going to be. It's going to return byte int. Data is byte like that. Okay. Code. Wait. Clock. None. Yeah, clock. Type equals none. Actually, I can just int. Like that. Clock. What are the others? High and low, right? high and low. Okay. And I want last clock or previous clock equals clock none, like that. 4. I equals 3. I is less than length of samples minus 3. I plus plus. Okay. Current clock equals oh, damn it. That's what they're going to look concerned. Otherwise, the clock check will be out about. Yes. Yeah. Somebody's looking at might also be a good variable whether rather than hard coded, at least if you want to accommodate large number. Yeah. I need to bind this to a type. Type decoder struct data samples is going to be int data is going to be byte yeah. What? No. Not that. Decoder equals decoder samples. It's going to be write dot data, and then data is just going to be byte like that, and then we're just going to do decoder dot decode. D dot is clock I. Is clock. I like that. This is clock. And that's going to return a clock type. I like that. So, adding an oscillation length field to the struct and doing the check based on I plus or minus oscillation length divided by 2. 44.1 and 48 aren't that far apart, so the peak detection might still work out with a hard code 3 samples per direction, but at 96 kilohertz or higher, it might cause problems. Yeah. Well, let's get something kind of working, and then we'll fuck with it. All right. And I'm gonna do in my own absolute function because the ABS in Go is a float 64. And I don't want to do that. I don't want to be using I want to use straight integers with this shit. So no. Absolute of x int int if x is less than 0, return x times minus 1, return x. That is really annoying. All of Goeling's math loops and floats. Yeah. Yep. Having absolute, max, min, and all that is so weird. Yeah, whatever. I don't know. So yeah, naming to return and needing divided by 2 seems annoying, but that's just details. Yeah. All right, absolute. Sign. Is there a dot sign for? That's not what I want to open up. There, it's fucking float again. That's sin. No. Oh, there's no sign. Sign bit. Sign bit reports whether x is negative or negative 0. That's dumb. All right. Sign x int bool true if positive, I guess. If x is less than 0, return false, return true. This doesn't really matter as long as, I guess, it returns the same thing for each, because that's what it's looking for over here. So whatever. That's an example of how to use generics or something. I mean, that the math package predates the generic by quite a bit. Aren't there inversions of those somewhere now? I don't know, maybe. This package does not guarantee bit identical results across architectures. Neat. Big bits, complex, rand. Package bits includes bit counting and manipulation functions for the pre-declared unsigned integer types. This is all uint stuff. I'm doing shit signed integer. Return. You know, that makes more sense. Yeah. The actual true false doesn't really matter as long as it's the same for, you know, for predictable shit. Yeah. That's fine. All right, do I need another math thing other than math.py? That's in the filter. We're not looking at the filter right now. All right, clock. If absolute of d dot samples I minus sample d dot samples I minus 3. If that is less than 500, why 500? I couldn't tell you. Peak delta. Let me func new decoder. Like that. Data int. What is this? Write dot data. Like that. I swear at some point around my only two lives would go. That's the spirit. Okay. Return clock none if abs d dot samples I minus d dot samples I plus 3 is less than d dot peak delta. Return clock none. You'll be the first one, probably not the last. Almost certainly not the last. Hell, I'm writing utilities for shit at work. I mean, those are more geared towards the specifics of crap at work. But it's shit like, hey, here's a file name, here's a PGP key, encrypt thing. Do encrypt. Do it. And another one is, hey, here's an encrypted file, decrypt it, thanks. Shit like that. I mean, I'm using other libraries, yes, but like, it's a lot easier just to throw it at one function instead of throwing it at like 4 and have to worry about shit. All right. The signals go to the same direction as both sides. It can't be a clock. Okay, so if sign d dot samples I minus d dot samples I minus 3 does not equal sign d dot samples I minus d dot samples I plus 3. Return clock none. Okay. Next, we're looking at the high and the low stuff. Okay. So, if d dot samples I is greater than or equal to d dot samples I minus 1 and samples I greater than or equal to d dot samples I plus 1 wrap that so I can actually read all of it. That makes it a little harder to read, but okay. And d dot samples I minus 1 is greater than d dot samples I minus 2 and I plus 1 is greater than samples I plus 2. Return clock high. Else if the other direction. Less than. Return clock low. I know that spacing isn't idiomatic. I do not care. I don't care right now. It's fine. Don't worry about it. All right. Okay. Kind of surprised about the missing equality on the plus or minus. I plus minus one. Plus. I mean, I can put them in there, but yeah, we'll leave it for now. Okay, so let's apply filter stuff. Let's go over here down to. Oh boy. Christ. Why is everything this massive if block? Hold up. No. Does he really do this? If clock type that shit. He doesn't invert and then just continue. He puts it all inside the if block. How dare? How dare you? We're not doing that. Okay, so if not clock current clock none and oh no if it's none or no and current clock equals previous clock. Did I invert that correctly? Did I invert that correctly? Where did I go? This right here. Because like this, I tend to use locals to simplify and make it clear, not to need the full data samples every time. Yeah, it's fine. Whatever, it's fine. Some language coding styles try to avoid early access and thus break continue return. Code does the opposite. Yeah. Oh, always the early ship. This is something that I had to kind of hammer into the intern because he nested shit like fucking mad, and I'm like, no, stop it, cut it out, continue here. If there's nothing to do, don't bother doing shit. Just continue. In an or, so the okay. An or. Oh yeah, because that would never be the. Well, if the previous clock was also none, but yeah, if it's an yeah okay, or it makes sense. Yeah okay. All right. All right. So I need to find the delta, the time delta, sample delta, time delta, sample delta. Yeah. We'll call it sample delta. Sample delta equals What? Oh, last clock. Last clock is bugger all, isn't it? Where's last clock set? Hang on. Last clock starts at 0. Okay. Decoder gets all the samples. Doesn't do any of that crap. Okay. Data last clock. Actually, that one could just be last clock to that. Line 250, yeah. No. Sample delta, okay. If sample delta less than 6, continue. Gap between clocks too small. I'll probably want some log information in here, but the 6 here is due to the plus or minus 3 in the clock detection. If you change the 3 there, you have to change the 6 here. Right. Okay. Yeah. Plus minus 3 in the clock detection. Okay, that makes a bit more sense. Yeah. All right. Last clock equals I. If sample delta is greater than 70,000, large gap, write out data. Why is there a retry count in here? What the hell? Hold up. Wait a minute. Wait. If retry count's less than 2, okay. And failed. Reset some shit. Go back to the top of the loop. No. How dare you? 1.56 between pages? Maybe. What is that? 4 seconds, at least. Yeah, so this one's 4 seconds. So yeah, at least a second and a half, I guess. I don't know. I deleted the rest of this one though. Let me open up. No. This one? Is this the full? Yeah, this is the full one. Okay. Whoa, not that far. Jesus Christ. Can you? What is that? 50 seconds. What? No. Starting at certain length. 3 seconds. 4 seconds roughly. No, jeez, come on. But then again, these aren't pages here. Let me turn off the spectrogram. These aren't like that. That's no, there's no data in there. There's a bunch of zeros. I don't know. Yeah, let's go with that for now. What do I have? So many of these fucking open. This is the 4800. We're gonna get rid of that. I don't care for that one right now. The current page is invalid. Try applying a filter and saving it again. Save page. This is just current sample position. Last save position, current sample. For now, I think I'm just going to dump out the raw data that I have as a page, maybe. And we'll come back to the actual encoding of the .StudyBox file. Most of this up similar to finding bits in the first and then decoding them. Maybe just store the peaks times in a slice or something and then detect gaps, find bits, etc. later. So start by just finding the clock signals, the high-low clocks. You're saying? These guys here. Seeing where their highs and lows are and the indices of that. Or at the very least, just a full slice of those clocks. Clocks. And that's not is clock. That's just going to be clock. Should we rather save the time and magnitude? The magnitude defining whether it's a 0 or a 1. Oh. Honestly, I think clock is interesting one here. They're really peaks, but basically just finding them first and then processing them later. This high and low doesn't tell us shit. I know, I realize that, but we'll get there, okay? We'll get there. Actually, we just fucking hang on. Switch C case clock none. Clock none. Case clock high. Loot low. Clock unknown. Code really provides high-low on time and finds bits from that because it's not the magnitude that defines the 0-1 bits, it's the time between peaks along with some info about the previous ones, if I stand correctly. But the high and low only detects an oscillation, and it's not a magnitude, where the data is actually stored. The oscillations should stay the same length. Should they? I don't know. I don't think that's really what I'm actually seeing, honestly. So if I zoom into here, whoop, some more. They are changing length. This one's longer than this one, which is shorter than this one, which is longer than this one. And the amplitude is mostly the same. I mean, there's some variation, sure, but yeah, it's frequency modulation, not amplitude modulation. That's AM radio, not FM radio. Then we only need the time in between, not if it's high or low. Well, we'll get there. Yeah, so out error equals os dot create. This is going to be a massive text file. Peaks dot text. Format dot f print line print f. It's out. Oh, we gotta if error is not nil, just panic. I don't care. Defer out dot close. It's fine. Don't worry about it. We want that and then S and then new line. This is gonna be. We're not zero padding that. I don't care. I and then current clock. No, you bastard. Declared not used raw. Cannot use a code value type int. Huh? As an error value in assignment. What? What did I... Int? What the shit? Int? Error. Return shit later. Don't worry about it. This is they're not use data. 185. Okay, ignore. No, let's return it, even though it's empty. Who cares? Then a previous clock. Don't care. Undefined samples. 197. Okay, game, how you doing? Average Linux users only browser. Not quite, but welcome. How you doing? You probably still want to skip the none and duplicate ones. This will just print out fucking all of them. Every single one of them, including the nuns. That will get to... Oh, yeah. Oh, you will get so many? So many. So let's kill it there. $1.7 gigabytes. Not a string. Okay, well, what if I call the string function on it, you bastard? Yeah, we'll still do this though. We'll do that. Should I do that? Okay. Previous clock. Oh, and I need previous clock equals current clock. How dare it? It most certainly. What do you mean? Oh, I'm not returning the. No, I am. What the fuck? Huh? Sting. God damn it. Not 1.21 gigawatts. The good old Sting function. Be that Sting. Oh shit! Okay, that one's so fast I didn't get a chance to tail it. Head and 50 peaks. Okay. Bee has stung. So the first low it finds is way over there. You would need to call string manually. Whatever, it's fine. I shouldn't have to call string manually now that I spelled it right. See? Maybe. We'll see in a second here. Hang on. Decoding. Yep. Curious how the printing doesn't take ages when you unlock every single data point as multiple bytes. We're going to take 2 bytes and use 17 bytes to store it. Shut up. Oh, God. All right. I've already got one of those open. This one. I'm gonna take this right, like that. Paste. And then we're gonna go over here. I'm gonna copy that, and then we're gonna hit minus. I'm gonna paste that. Paste that. Paste! You bastard! Paste. Equals 6. Ha ha! 6 whole samples. Neato. Does that for S2? If he wouldn't have told you the funk was missing, just printed the int instead. Well, sure. That's to be expected. Right. Yes. Yeah. It's at least 6. Right. Yeah. And it's the difference there that, yeah, okay. When we get more than 6, we have a 1-bit, presumably, right. Sample delta. Let's get this guy. Last clock is I. Like that. What's the... Hang on. Just gonna do that. I'm just gonna put a space in there so I don't have to worry about alignment. Because shut up. D, and then that's going to be sample delta, because I want to see what the deltas are. And I don't want to bother saving one of these channels all the time. This one, I don't care about it. I'll read it in, sure, but I don't care about it otherwise. Undefined last clock. Go to hell. So I commented out and I uncommented again. Previous clock assignment after the sample date. Why? I mean, yeah, okay. That's 12 million samples from the last. Yeah. 6, 9, 9, 10, 9, 9, 9, 9, 10, 9, 9, 9, 9. Sorry. Yeah, okay, so this is halfway there. Previous clock with last clock. Yeah. Oh, fuck. That is confusing, isn't it? Yeah. Because the current clock and previous clock, that's a clock type. High, low. So that's peak. Let's change that to peak. Changing all these to peaks. Okay. Bridgewater, how you doing? Which I can't use in Shiritori. Why not? What? Improve time. Doesn't improve. You know, we'll get there. One of 9s and 10s. Looks like it. Looks like lead in. Oh yeah. Oh yeah. And then eventually here, we should start seeing a bunch of other crap, right? Maybe? I don't know. Or it'd be shorter, yeah, like the shorter ones like this, right? 1, 2, 3, 4. Right? Maybe? I don't know. Whoa, no, never mind. There it is. Wow, okay. Yeah, so this is the lead in. And then we got some data. Got it. All right. Higher. Yeah. What does it end in? Yeah. You can't do it because you can't start the next word. Right. With doesn't start any words in Japanese, right? Yeah. I expect smaller diffs for ones, if I understand encoding correctly anyway. I don't know. I certainly don't understand it as well as I thought. But we're learning, you know. Yeah, I don't know. All right, so peak. Previous peak. Peak none. Last clock. We'll keep that at that. Peak current peak. Whoop. Peak none. Previous peak. Current peak. Okay. I don't know if that really helped me with yeah, maybe, I don't know. Previous type and previous time would have been my recommendation. Oh well. Does this still work? Nope. Undefined. Clock type. 130. 130. Oh, yep, I didn't do these either. I kept going back and forth on the... Is this an isosynchronous encoding question? Working on the decoding started with knowing what data the firmware was looking for as a page header and trying to line that up with the waveform transitions in the actual page headers. Yeah. Yeah, right now I'm trying to basically make heads or tails of the... I'm trying to understand the underlying encoding, I guess, by looking at Sour's code and changing it as I go. Because, yeah, I had some trouble re-decoding stuff. So I had to look at a source code and saw all kinds of hard-coded shit. I'm like, ew, that's disgusting. So stuff was hard-coded at... Or to... The data coming in needs to be 44.1 kilohertz, signed 16-bit little endian PCM data. I want to be able to take in fucking anything. Audio data, yes, go! And from there, be able to, like, depending on its sample rate and all that kind of stuff, still be able to figure stuff out. Have you taken a refresher look at my documentation thing? Yes, I actually have that open. Not there. Right, not there either. Right there. So yes, a little bit. I've also got Wikipedia open in the background as well somewhere. Yeah. It's starting to make a little bit of sense, especially now that I'm visualizing rather. I don't know, is this gonna do its thing now? Yeah, especially since I am able to visualize a little bit the samples themselves, right? That's what this stuff right here is. So that's the sample index, the higher low bullshit, and then this is the delta from the previous peak, higher low peak, right? So yeah, lead-in data, and then way the hell down here somewhere, quite a few seconds later. Come on. Because I'd like to be able to infer the clock out of the data. There it is. And then there's actual data here, right? So it's starting to make a little bit of sense, kind of, sort of, for me. Yeah. You're doing peak detection. I was doing zero crossing. Oh, okay. So you're doing. Oh, so this is what this is how Sour's doing it. He's doing the peak detection. So you're doing it where it crosses the from top to bottom kind of thing, right? So right there, you're doing the detection essentially, positive to minus, right? Whereas I'm trying to find the peak of it, each of the peaks. Only because that's what Sour was doing. So, yep, picking up the sign bit and the samples. It should amount to pretty much the same. Yeah. Yeah, because then you're just looking for the change in the sign. Yeah, I mean, would you need to look for jitter? So would there be across three samples? Would there be one minus, positive, minus that fast? So could you just look at two samples and see if it changes there? Or do you need to look at more samples? Because what he's doing here, he's looking at a bunch, or we're looking at a bunch of samples. We're looking at, I don't even know how many samples. 6 samples to determine if it's a peak or not. Ideally filters out noise while looking at an absolute magnitude as a minimum. Right. Look at more for noise prevention. was pretty stable. Yeah. Where's that ugliness that I saw in this one? Was it this one? Yeah, oh yeah, in here. Right? If I do that a little bit. Yeah, this nastiness right there. This crap. Because this is all in the lead-in, I think, right? Yeah, there's the actual data. The lead-ins. This is all should be all a single tone. I mean, it is, but it's got variation in it, you know. Because the zero crossing is in the fast-moving part of the signal. Yeah, all right. Either more samples are probably better, have minimum amplitude. My interest was in the figuring out the format, not implementing the decoder. True, yeah. 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 Look at 7 total. The one we are looking at. And oh, that's true. Yeah, 7 total. Yep. No. Yeah. But okay, so we have the sample delta, and this is really what we need right here to figure out the data, right? Where's his code? Right here. This is just figuring out where the page is. I don't care about that right now. Try. Fuck. I hate that. I hate that so much. Time gap. Try to find another. Okay, again, I don't really care too much about because again, that's saving a page. Don't care about that right now. Time gap. If it's greater than 20, gap too large. Greater than 20, but less than 1,000? Why? If the data started. Like it's missing data in there somewhere? I don't think I care for that right now. Last bit. Now that I have this airport, use zero crossings too, but since we already have the peak detection, no point in changing it out. No. Get a volume variation in the data channel. If that affects both channels, like speed variation clearly has to, then you can correct that too. Oh. Yeah, so if you... Okay, so you find a peak and you record its amplitude, right? And average that over a second or whatever, right? Or you find, like, the proper amplitude that it needs to be. Then you'll be able to see how much each peak differs from that amplitude and be able to use that to correct it, right? Maybe? I don't know. Kind of talking on my ass, not gonna lie. All right, so basic ideas. Okay. Try to find another. I don't really care about that right now. I don't get this code. If the gap is less than 11, it's a 1. So lead is all ones. Lead is all zeros followed by a single 1. Right? Yeah, the lead-in region for a page is a long string of consecutive 0 bits, terminated with a single 1 bit. Yeah. That works with lead-in list. The data seem to have more amplitude variations and tenacity. Sort of like how you can use the peak-to-peak differences to map short time variation in the tape speed. So 10 and 9 should indicate ones. I guess? I think so. Or indicate zeros, rather. Because that's the lead-in. And then... there's a 14. So that would be a 1, right? According to code, it's ones. I don't know. I think it depends on what the previous bit was. Thank you for the file. Appreciate that. Yeah. That's actually into the data region. The data region consists of repeated sequences of a 0 followed by 8 data. MSB first. Because the 9th bit is guaranteed to be a 0. Encountering a run of 9 or more consecutive 1 bits means that we are reading the lead-in region and are desynchronized by half a bit. Half a bit. It's the lead-in. This synchronizes the decoder state since you can't have more than so many zeros in a row, so many ones in a row. Right. Yeah. So if we have 9 ones in a row, we need to we need to resync. Yeah. Does he even do that? I don't think he does that, does he? There's a 0-bit counter. Expect our turn. Yeah, he doesn't count 1 bits. Where's the add bit function in this? Yo, man, how you doing? What's the best video game of all time? I don't. What? It's entirely subjective. Add bit. If data started. Can't do like a return early on this. Asking my subjective. Shit, I don't know. I can't give you a clear answer off the top of my head. I don't know. There's games I spent hours in. Too many hours. Did I? Oh, I caps on. I don't know. He does this like freaking everywhere too. I can't stand this where he puts everything inside of an if block. Does he look at last bit in this? No, so that should be up here. Last bit should be up here. And then if not data started, return. So then this shit can be like that. Sour, what the hell? I like this jumping guy around the mushrooms. You get really high. It's not balls. But I digress. I'll put it back to how he had it. All right. If you expect 0 and the bit is not 0 and data is started, 0-bit expected. Start a byte marker. Position. That. Failed. It fails instead of realigning. 293 to 307. 293. To 307. Here's 307. 93. Okay. So if the last bit is 1. I thought this was the more straightforward part of this code. So it's, add a bit. The 1 bit if the gap is less than 11. So if the gap is between 6 and 10, and the previous bit was a 1, we add a 1. Otherwise, we add 2 zeros. Otherwise, we add a 0 and a 1. Yeah. That's for finding an interbyte 0 bit, not a lead-in 0 bit. Right. Right. Yeah. I don't get why. I can't answer that for you. Not yet, anyway. I don't know. I don't know. Where was I, though? What was I? What was actually in the code here? All right, so I want to have a look at the sample deltas. Okay, so I'm ignoring these two right here. I'm just straight up fucking ignoring them for now. I'm not even gonna bother doing that. Last bit. I need a last bit. Last bit. Int. Screw it. I think both the string of zeros and a string of ones would be deltas of 9 or 10, while a mix has longer deltas. Thus, needing to know the previous bit to determine what a given delta should be to decode it. So it directly contradicts what we found through what we did before, in the case that 9 and 10 indicated 1, but not necessarily. No, it's a state machine. Well, it's the kind of state machine, right? Where it's not like, oh, this gap is a 1. No, it's this is a 1 because the previous one was a 1 kind of thing, right? Sorting the wavelengths into 3 buckets, then dispatching on what it tells us about the decoding state. That's probably for the case that the last transition was for a 1 bit, was in the middle of a bit period. Yeah, let's get the func D decoder. Add bit, but bit. Int, B int. Yeah, int, screw it, it's fine. And why am I giving, why I? What is I there? What is I doing? Add bit int I, okay. Oh, that's just for the log. That's all that is. There's reasons to ask it. Yeah. Yeah, it's diagram right here. This didn't tell me shit. Oh. All right. If data started and you're expecting 0. All right. Else, if the bit counter is greater than 0, bit counter current byte. Huh? Bit counter equals 0. Raw data to add current byte. Okay, so that's keeping track of the current bit. Got it. So, do I have last bit? Current byte. Byte. Like that. Data started. I don't care about the looking for data started yet, I don't think. Got a last bit. I just could assign that to B. If expects 0. Expect 0. It's only if data is not started. Ah, jeez. So this is okay. So this is not. This is skipping over the lead-in, obviously, for the data. So it's not recording the lead-in as any data, which I'm not filtering out right now because I don't want to be bothered, but I have to be bothered apparently. And I think I'm running out of steam for this, honestly. If I'm being honest. I'm running out of steam a little bit. So I might just like try and continue this later. Once I'm more, I need a coffee, and it's too late for a coffee right now. Yeah, so I might try to hammer this out a little bit more tomorrow, and then on Sunday as well. Yeah, because again, I think I understand it at a high level. Like, for me, I more or less think I get what the graph is telling me. I think. Maybe, I don't know. I gotta read it again when I'm awake. Honestly, coffee sounds so good. Coffee's so good. It's a little late for that right now, though. The last one was 0. You can only have a short 2 half period or a medium 3 half period half wave corresponding to a 0 or 1 bit. Yeah. Yeah. I understand. I'm not absorbing it right now because I'm exhausted. But yeah, I get the basic idea of, you know, given the previous bit, the next bit, the next two, yeah, I get it kind of, yeah. So peaks first, then you only need to look for lead-in when decoding the peaks, which you can do separately. First, a function that skips the lead-in and returns what offset to start decoding data at. In that I think detect, well, so I can detect the no peak crap, right? That's that right there. The last bit was a 1. Then you can short. Then you have a short, right? 2 half period indicating a 1. A medium 3 half period indicating 2 zeros. Or a long 4 half period indicating a 0 followed by a 1 half wave. Ah. Right. Yeah. Turning that into code is going to be a tomorrow task for me. Like I said, I get at a higher level, but I'm too tired to really process it right now. I'll get there. I'll get there eventually. Yeah, so and it seems like the steady run of sample bit is always a short run of half waves. A steady run of the same bit is always a short run of half waves. Yeah. Yeah. But yeah, so it seems like the work I'd have to do to make this compatible with other sample rates is basically just scaling this to the sample rate, right? Scaling these numbers that he's checking for. Oh, where is it? Scaling this stuff, right? The time gap. scaling those to whatever it would be in that sample rate, because this is all hard coded essentially for 41.1 or 44.1 kilohertz. Yeah, because I would like to do or be able to do, you know, higher sample rates than that. Just, you know, shits and giggles, I guess. I don't think those need the sampling rate, actually. You sure? The question is, how strict is Messin as to the audio format? As for the recorded audio, good question. I don't know. I'd love it if Messin could do MP3. That'd be fantastic, but I know it can't. Yeah, I don't know. I'd need to figure out resampling otherwise. They only need to be adjusted to the distances you find in the lead-in. I don't know if that's right. Because the sample rate affects how many individual samples there are per second, or per unit of time. So that would change how many samples I'm looking for in the gaps, right here in the time gaps, the deltas. Right? Am I understanding that correctly? Which is why when I tried to decode the 48 kilohertz, it yelled at me. I think it was this one. Yeah, the gap too large. These guys. It was yelling at me. Because the peak detection or something was off, or not off, but the peaks were further apart in samples than it expected. Right? The distance of the peaks and lead-in depends on the sample rate. Right. Yeah. Exactly. Oh, yeah. Maybe adjust it to the distance you... Oh, I see what you're saying. But you know what? I see what you're saying. So you get it... Right. So you get the sample rate from the lead-in itself. So you wouldn't have to necessarily read the sample rate out of the audio format. You just... the header of the actual audio file or whatever. In that case, you don't really need to care. You just need to figure out what the gap is between the peaks in the lead-in, because you know that the lead-in is always going to happen. So it's going to start with the lead-in. Yeah. I think you just do it for whatever you want. Can this actually... how high of a rate can I actually record in? That's my curiosity. How would I check that? This is leading to find the this between the peaks, which is what matters to you. Yeah. My audio and my audio interface, that's what it is. I think that one can only do 48 top. The other one that I don't have working yet, which I've had for fucking 2 years at this point? Shit. I need to really get that working. That one, I don't know what that one can do. Let's see. Oh, they don't even have okay. There's audio interfaces, StudyBox series. OSB 96. Let's have a look at that. Doesn't say. Doesn't even matter if the WAV file is mislabeled, has the wrong word. Yeah. Doesn't matter if the tape was played at half speed or something, as long as it's a reasonably constant speed. Yeah, this doesn't give me like a sample rate that it'll do. Wait, hang on. Preamp, line inputs, impedance, digital audio. This one will do 96 kilohertz. Really? I wonder if I can actually record in that. Oh, Control Z on that, Control Z on that, Control Z. Fucking. Whatever, doesn't matter. File, new. Close that. No, don't save. Play on that. Rewind it first. Play. Record. Disk space remaining for recording 71 hours. Not bad. Joe, that's loud. Yeah, I mean, I guess it can. 9600. Look at that. Shit. The variance in the delta between the encoded zeros and ones is fairly small. Only one in this. So you could probably even dynamically detect the range by a single magnitude and difference. So, yeah, something like that. After a little bit here, I'll zoom in a bunch to have a look at the individual samples. As long as the speed doesn't change too quickly, it shouldn't be too hard to adjust on the fly. Yeah. And if I keep track of that adjustment, I'd be able to correct an audio track as well, the recorded audio, to remove any distortion. Allegedly, right? I'll let it go past this one, and then I'll stop it. And the end of it. Come on, where are you? It's here somewhere. There it is. Stop. Whoa! Oh no! Drop-offs. Oh, that's at a regular interval too. I don't like that. Let's okay, we're gonna split to mono, get rid of that one because I don't care about it. Gonna have a look at the spectrogram real quick. Oh god, look at that. Oh Jesus. Waveform. Yeah, see, that's a lot more samples per yeah. So yeah, that's a few more samples per peak. Just a few. Even with that dropout though, like that doesn't look that bad. So the other day I was I was recording another tape because I shut up. But I was also re-encoding some video. Every second had like 4 clicks in it. It started so bad. I'm like, oh, that recording's just garbage. Okay, I can't use that at all. Like it was very noticeable in the audio, like unbelievably noticeable. This, not so much. Not so much with this. especially if it's just like one every so often. All right, it is in there. Nah. Yeah, I don't know. Not that I can really use it this high, but yeah. But anyway, I am tired. So compression markers? No. It's compression chunks? Not quite. Nope. It's my computer not keeping up with recording the audio. That's basically what it is. Dropouts may be more of a problem for data than general audio too. Yeah, probably. But yeah, that's a problem for another time. I'm not really gonna worry about right now. Yeah, because like the 44 one works well enough for the decoding stuff. So I'm not too worried about it, I guess. Yeah. Anyway, gonna get my ice cream now. You enjoy that. But yeah, I think I'm gonna wrap up. I am tired. I'm tired. So yeah, let's see if there's anyone else to say hi to real quick. I'll probably be doing more of this on Sunday, honestly. If you're recording at a higher rate than it was recorded at, you will naturally have gaps in the data or wrong data. You can't create data out of nowhere without errors. Well, right. But I don't know. Yeah, I don't know what the tapes are mastered at, honestly. I'm not sure I'll be able to. I probably won't be able to figure it out. I don't know. All right, let's see. Go to following first. Rest well. I'm certainly going to try to rest well. Live. Who is on? Doing a thing. I think we'll go over here. Yeah. I don't think I've said hi to him in a while. There was a network error. Please try again. Twitch, go to hell. It's adding more shit. Come on. There you go, Twitch. There you go. Come on.
Well,
No, I don't want it.
but-
I'm not knocking Twitch.
Never be like
Fuck
that.
off, Twitch.
Yeah, it's a bit different. It looks close though.
But yeah, thank you for being here. Appreciate it. I will see you next time. Please come with me to say hi to Jitspo. I would really appreciate it. Yeah, I will see you guys Sunday, I suppose. I don't know. Bye-bye.
It looks like a lighter gray than it already is. Shouldn't that be like shallow gray? Are there any themes that get rid of the rounded corners? Or do they just